Okay, let's try a sample problem where we are going to calculate the molecular formula from a percent composition. And if you look at this question, it says a compound is found to contain 75% carbon, 25% hydrogen by weight. That should look familiar because we did that in the last program when we were determining empirical formulas. We want to take and find the empirical formula, so we're going to do that again, and then we're going to take that information along with the molecular weight for this compound, which they gave to us, which is 64 grams per mole. Just make my pen smaller. Okay, what is the molecular formula? So let's see how to do that. First step, first thing we're going to do is we're going to take the percent composition. So we have carbon and we have 75% of it, and we have hydrogen and we have 25% of it, and we're going to calculate the empirical formula from this information. Because once we have the empirical formula and we have the weight of what the molecular formula should weigh, we can find out what number multiple that molecular formula is going to be of that empirical formula. So going back to our steps for calculating empirical formula, we're going to write down the percentages, that's step one, and then we're going to change those percentages to empirical, to grams, because we're assuming that we have 100 grams. So we can do that. Every time I change to an eraser, I have to change the size of my pen, so just hold on with me for a second. We change 75 grams to 75% to 75 grams because 75% of 100 grams is 75 grams, and 25% of 100 grams is 25 grams. So now we have grams. We're on to step two, and step two said we're going to take the grams and we're going to divide by the molar mass of carbon, or the atomic mass of carbon, and that's 12 grams per mole. And when we do that, we get 75 into our calculator first, divided by 12, gives us 6.25 moles, not grams. I was getting carried away with myself here. Okay, sorry about that. That's moles. Okay, and then we have 25 grams divided by 1 gram per mole, and when we do that, we simply get 25 moles. Okay, that's the second step. Now the third step was to take these numbers, because this is my molar ratio. Remember, we got 6.25 as the subscript for carbon, and we got 25 for the subscript for hydrogen. Well, that doesn't work, because if we're looking for an empirical formula, they have to be in the lowest whole number ratio. We don't have lowest whole number ratio right now. This is not a whole number, and it's by nowhere near what the lowest it can be. So to get this to be the lowest whole number ratio, we're going to divide both of these by the smallest number. Let's change the color so you can see better. 6.25 is smallest out of these two numbers, and 25 divided by 6.25, and we're going to get carbon with a subscript of 1, because 6.25 divided by itself is 1, and hydrogen with the subscript of 4. 25 divided by 6.25 gives us a subscript of 4. We don't have to write this 1, so our empirical formula looks like this, CH4. Okay? Once we have that information, we can now determine what its empirical mass would be. So I'm going to erase this just so that we have room, and I'm going to write CH4, that's our empirical formula, and I'm going to calculate the empirical mass. Basically, what does this thing weigh? What's its mass? So we've got carbon, there's one of them, and it weighs 12 grams per mole. We've got hydrogen, there's 4 of them, at 1 gram per mole apiece. So 12 grams per mole plus 4 grams per mole. All I did was multiply 4 times 1, got 4. So 12 plus the 4 gives us a total of 16 grams per mole. Well, in our problem, we were told that the molecular formula weighs 64 grams per mole. And if you recall, from the last program, if we had CH4 times 1, then its mass would be 16 grams per mole. If we had CH4 times 2, then it would be 32 grams per mole. If we had CH4, let's write this so that you can see what I'm doing. CH4, this would be C2H8. That's 2 times this C3H12. That's 3 times this. CH4 times 1 gave us CH4. CH4 times 2 gave us C2H8. CH4 times 3 gave us C3H12. So this is going to be 48 grams per mole. I'm going to run out of room here. And then if we go times 4, oh, pen, don't die on me now. It just died on me, as you can see, this little circle thing. This program is giving me a little trouble. Okay, let's see if we can salvage this. Of course, it's going to give me trouble. Okay, well, let's keep going, because I've done this many times. So we had, fudge. Okay, CH4, which weighed 16 grams per mole. We had C2H8, which weighed 32 grams per mole. We had C3H12, which weighed 48 grams per mole. And this is where we are. We want 64 grams per mole. So C4H16. Well, 4 times 16 gives us 64 grams per mole. So this is our answer. Alright, I'm going to reset this and hopefully I can get the pen working for the next one.